Hello there, welcome back and welcome to a how-to video. Today I am showing you how I go about soldering. This is a video that I'm making because of popular request. Quite a few people have asked if I would show how I go about soldering, so that's what I'm going to do. So we'll start off by talking through the different equipment that you need. Then I'll go on and actually show you how to sort of set up, prep, get ready. Then I'll do some actual soldering, and then I'll finish off the video by showing some common mistakes that people make when they solder, and also how to go about fixing them. So hopefully this will teach you some stuff. Please do bear in mind, this is just how I do it, this is how I was taught, and this is how I've done it ever since. I'm sure some people will do things slightly different to me, and that's absolutely fine. Hopefully this will give you some sort of tips and hints on how to get better quality soldered joints. So without any further ado, let's crack on. So let's start off with the obvious and look at the actual soldering iron itself. A soldering iron is something that takes electricity and turns it into heat. It's that simple. This is about as cheap and cheerful a soldering iron as you can get. I think I paid about £15 for it about 10 years ago, so I've definitely got my money's worth. But really, I don't need anything more than this. You can pay pretty much what you want for a soldering iron, and it all comes down to the performance that you want. This one just gets to a certain temperature and then it stays there. It just turns on when it needs to and turns off when it gets hot enough. You can buy soldering irons that you can set the temperatures on, and clearly they're a bit more expensive because they have more sophisticated control systems inside, but it just depends what you need. Now, this is a very low powered soldering iron. This is only 15 watts. And I don't really need a huge amount of power because all of the joints I do are very, very small joints. If you think about all the soldering I've done on my model Titanic, I'm soldering tiny little LEDs together or tiny little wires, tiny components, small resistors, that sort of thing. So you don't need a lot of power to heat these things up. If I was soldering bigger wires that were going to carry a decent quantity of current, this soldering iron might not give enough power output to actually heat them up successfully. So if you were doing thicker wires, you might need a bigger soldering iron. But for me, 15 watts is absolutely fine. The only other thing to think about with the soldering iron is the tip. You can get tips in all shapes and sizes, big ones, small ones, fat ones, thin ones, whatever. On this soldering iron, the tip is actually removable. I won't take this one off because it's one of those things, you can only take it off so many times before something snaps. But this is the tip I use. This is a particularly thin tip. And again, I use that because all of the joints I do are very, very small. So it's useful to have something really thin that you can get into tight corners and stuff like that. If you want to do bigger soldering joints, again, on things like bigger wires and stuff, you can get different tips. This is a thicker tip, and you can see the state it's in because I hardly ever use it. But this is a much thicker tip. And so this would be useful again if I was soldering thicker wires and stuff. But again, horses for courses. For me, a thin tip is absolutely fine. Now, once you've got your soldering iron, you need somewhere to put it. Remember, when this is turned on, this tip will be extremely hot. So you need somewhere to put your soldering iron to hold it securely when it's not in use. Otherwise, it'll just melt or burn anything that gets in its path. So you need something like a stand. This is my soldering iron stand. And it's good because it's got a tray here for a sponge with some water on it. It's got the actual stand that holds the soldering iron, and it's also got this pillar which allows you to clamp useful things on, and I'll go into that in a bit more depth later. Now, when you buy a soldering iron, you often get a stand with one, and my advice to you is to throw those stands in the bin straight away, because normally they're just a thin piece of pressed metal which just sort of holds the iron like that. And it's all very well, it does hold the soldering iron and it stops it touching anything, but what will happen, and I absolutely guarantee you this will happen, is at some point you'll come along and you'll have put something behind that you need, and you'll go to grab it and you'll touch the tip of the soldering iron with your wrist or with your hand, and it really hurts. Trust me, I have burns all over my hands where I've touched soldering irons in the past, and it is bloody painful. You don't want to do it. So the remedy to this thing is to get a stand like this, which shrouds the entire tip. You see, this coil thing shrouds the entire tip, which means that when the soldering iron is in its stand, You can't touch the tip, you can't burn yourself. It's much better. It's worth doing. I know it's a bit more expensive, but it's worth doing because it really does hurt very badly when you touch a hot soldering iron. Now, as I say, you can get various different accessories to help you when you solder. One that is absolutely essential is some form of clamping whatever you are soldering. So if you've got a circuit board, you need something to hold the circuit board in place while you're soldering. Now, my soldering iron stand comes with this sort of bizarre sort of beastie, which has crocodile clips on. So I can manipulate this however I want. And I can put my component or my soldering iron or my circuit board in these crocodile clips, and it holds them in place while I solder them. It's really useful. So something to clamp and hold on to the things that you're soldering is essential. You can get a few other things. I don't really tend to use anything else when I solder. I got this with the actual stand. This is a magnifying glass. I very occasionally use it, but I don't use it very often. But it can be quite useful, I suppose, if you're doing really fiddly small joints. But most of the time I actually leave it off because it just gets in the way. Now you also need something to clean the tip of your soldering iron. I have this. This is like a sponge which you just soak with water and you put it in the stand. And that's great. I got it with my soldering iron stand and it does very well. If you don't have one of these though, don't worry, you don't need anything that sophisticated. This is a piece of kitchen roll soaked in water and that will do just as good a job. So the other thing you need, and perhaps the second most obvious, is some solder. So what is solder? Well, essentially it's a drawn wire which is made of a alloy of different metals. My solder is 60% tin, 40% lead, but you can get lots of different types. Lead is becoming less popular these days, although I still quite like it. Just be aware of it. If you're using a leaded solder, don't stick it in your mouth, wash your hands afterwards, just be careful with it. Lead can be quite dangerous. The special thing about electronics solder though is that it's impregnated with a chemical called flux. So why do we need flux? Well, when you heat up a metal, it tends to oxidize quite quickly. The surface of the metal gains a layer of oxidization. So of course when we put our soldering iron onto a circuit board to create a soldered joint, the two things that we're trying to combine together will gain a layer of oxidization. And oxidization is hopeless for an electrical connection. It massively increases the resistance. So when we add our solder, the flux starts to boil under the heat. And as it boils, it strips away that layer of oxidization, and it also removes any other impurities, and it ends up leaving us with a really, really clean joint, which is perfect for an electrical connection. So that's why flux is so important in electrical solder. Now, just like soldering iron tips, you can get electrical solder in lots of different shapes and sizes. Thick wire, thin wire. I tend to use a very thin wire for my electrical solder, and again, just like my soldering iron tip, that's just because I tend to do very small joints, so a thin wire gives me a lot more control. If you're soldering very thick wires together, then a thicker solder is probably more useful. But again, as with most things, horses for courses. Now, another few things that are useful to have. Firstly, a good pair of snips. When you're soldering components, once you've made the joints, it's useful to have a good pair of snips to cut off excess bits of leg, that sort of thing. And also, you need something to undo mistakes when you make them. So this is a solder sucker, and I'll show you how to use that a bit later on, but essentially it does what it says on the tin. And there's also this solder wick, and again, I'll show you how to use this a bit later on in the episode. In an ideal world, you wouldn't need these things, but let's be honest, at some point, I am sure you will, I don't know, you'll solder something and then you'll realise you've put the component in the wrong hole, or maybe you'll use a bit too much solder on a joint and you want to remove a bit, or maybe a circuit board will stop working and when you look at it you discover that a component's broken and you need to take it out and replace it with a new one. Either way, it's useful to have a means of either repairing or completely removing soldered joints. So these will come in handy at some point. Well, first of all, you need a decent amount of space. I tend to work in my kitchen because it's very well ventilated. When you solder, it produces a few gases and fumes get emitted, so it's good to work in an area that is well ventilated. My kitchen also has an extractor, so if it gets really bad in here, I can just turn the extractor on and leave the room, and that's absolutely fine. It's worth saying that you can get extraction units specifically designed for soldering irons, which actually, suck away fumes before they have a chance to disperse into the atmosphere. I don't personally use one because I don't really tend to do enough soldering for it to become an issue. If you're going to do a fair amount of it, though, that is something that's worth considering. So, soldering iron is now in, and it's switched on, so that's now going to be heating up. While the soldering iron heats up, I'm going to set up everything else. So, while we're waiting for the soldering iron to get up to temperature, I'm just going to flood this with water. It doesn't need to be absolutely saturated, but it does need to be damp. If you're using kitchen roll, exactly the same process. Just make it damp. I'm squeezing that and water's not flowing out, but it's wet. That's all you need. Now, first things first, before we do anything else, we've got to clean the tip. Now, this is something you should do periodically anyway, but I always do it at the start and the end when I've just turned my soldering iron on and when I'm about to turn it off. So, to clean the tip, what we need to do is just introduce a bit of solder wire to the soldering iron and let that sit on there. What's happening now is the flux in the solder is just boiling around and it's clearing off any oxidisation on the tip. Then just wipe it on your damp sponge or your damp cloth. And there we are. Perfectly clean tip, ready to go. So to demonstrate the soldering, I'm going to use this. This is test board. It's just a type of circuit board where you can sort of mock up circuits and prototype on. It's very useful, and I'm going to use that for my demonstration piece today. And I'm going to solder a selection of components. I've got a fixed resistor that I'm going to solder, and I've got two different types of variable resistor that will solder as well. So before we actually go anywhere near this with the soldering iron, we need to make sure the component's in properly. I've just put this through 2 holes, and a good technique is just to bend the legs over a wee bit, and that just stops the component falling out when you're actually soldering. So you can see that the resistor is on the board, just off it, and that's good practice because it allows a bit of airflow underneath, and the legs are bent, so they're not going to move anywhere. The component's not going to move as I solder it. Now I've got the magnifying glass here so that you can see what's going on. What we're going to do is we're going to touch the tip of the soldering iron, and we're touching it onto the leg of the component and also the track on the circuit board. The aim here is to get the two surfaces hot enough to accept the solder. Just brush it against the soldering iron and you'll see that the solder's flowed onto both the leg and the track of the circuit board, and then remove your soldering iron and you've got a lovely joint. So next, let's have a go at soldering this variable resistor. What I've done, you can see I've just bent the legs at disparate angles, and that again, it just stops the component falling out or being pulled out during the solder process. So what we're going to do is we're going to get our soldering iron and we're going to place it so it's touching the track and the leg of the component. Then just touch some solder and brush it against the soldering iron. Remove the solder first and then remove the soldering iron. And there we are. Same again. Touch the soldering iron so it's touching the leg and the track. Then brush the solder against it, remove the solder first, and then remove the soldering iron. One final time, touch the soldering iron so it's touching the track and the leg of the component, touch some solder against the soldering iron itself, take the solder away, and lastly, take the soldering iron. Now with soldering, less really is more. The less solder you use, the better normally. If you use too much, you run the risk of bridging, which is when you accidentally connect two things together that you didn't want to, which is, not good. As you can see, the sort of ideal shape for a joint is like a sort of mountain where you have a pool of solder at the base on the track and it sort of like tapers up towards the leg of the component. So now I'm going to show you a couple of common mistakes. Here I've done a resistor, and on one leg I've done one common mistake, and on the other leg I've done another. So let's focus on this one here first. You can see that the leg is actually able to move in the hole. And you can see that what's happened is the solder has pooled around it, but it's not actually touching the leg at all. Now what's happened there is that I touched my soldering iron onto the track, but I didn't touch the leg of the component with the soldering iron. So what that means is the track heated up, the leg of the component didn't. So the solder flowed around the track, but because the leg of the component was cold, the solder didn't flow onto the leg. So that's a very common mistake. Do you remember when I was actually doing the soldering for real, I was quite clear in saying make sure that the tip is touching both the track and the leg of the component. This is what happens if you only touch the track. On the other side, you can see that what we've got is the solder sort of floating off the circuit board. Now what's happened here is I've done the exact opposite. What I did is I touched my soldering iron onto the leg, but I didn't really touch the circuit board at all. So you can see that the solder has pooled on the leg, but it's not really flowed onto the circuit board. So this is a very similar error and results in a very similar problem. But just that the leg in this case was hot enough and the track wasn't hot enough, so the solder didn't flow properly. So there's a very simple fix for both of these, which I will show you now. All that you have to do is essentially redo the joint. Touch your soldering iron until the old solder melts. And you see what I did there was I touched the soldering iron onto the track and the component, the solder melted and then reflowed properly. If you're a bit worried that there's not enough solder, just add a bit more. It's that simple. Same on the other one. So this leg, this was when I'd applied my soldering iron to the leg but not to the track. Same thing, just touch it onto the leg and the track together, and you see that as the solder liquefies, it flows properly. And again, normally sensible to add a little bit more solder when you do that. The reason why I add a little bit more solder when I do that is because remember what I said before. This solder wire has flux impregnated into it, but as it heats up, that boils away. So when you remelt solder that you've already used, that flux has already boiled away. By adding a little bit more solder, you're just reintroducing some flux again. So you're able to clear off that joint again. You're able to get rid of any oxidization. Now, one thing I often see people doing, which I don't really agree with, is melting some solder onto the soldering iron first and then plopping it down onto the joint and sort of wiggling it around until the solder flows where you want it. Now, to me, I don't think that's a very good idea, because first of all, melting the solder onto the soldering iron means that you're boiling off a lot of the flux before it gets anywhere near the two metal surfaces that we care about, which is of course the leg of the component and the track that it goes onto. And secondly, it means that we run the risk of not heating up the two metal surfaces that we care about enough, because we're not holding the soldering iron on the actual joint for anywhere near as long as we would if we soldered in the way I've shown you before. So if anyone knows why people do that, let me know, but to me it seems like a slightly curious way of doing it and I wouldn't recommend it. Now, the other common mistake I see people doing is holding the soldering iron for far too long. Holding it there for ages and ages and ages and ages and ages and ages, and then putting a bit of solder on. Then going off and then thinking, it's not quite perfect. Okay, hang on. Still not perfect. Essentially what they're doing is they're leaving the soldering iron on for far too long. These tracks on the circuit boards are glued onto the fiberglass beneath them. And the glue is very good, but repeated heating up, cooling down, heating up, cooling down, heating up, cooling down will eventually result in the track lifting off the circuit board. And at that point, you really are in a bit of trouble, because there's not a lot you can do about that. I know it's hard when you're a beginner and you're trying to get a really good joint, but resist the temptation to go back to things unless you really have to. Most of the time, any decent joint will do. You don't need to spend 30, 40, 50 seconds holding your soldering iron on. It's quite a quick process. Again though, this is one of those things that you will get better at the more that you do. So the last thing I want to show you is how to remove solder. Maybe you want to remove a component, or maybe the joint's a bit damaged or whatever. So the first method is to use a solder sucker. This is a device that simply sucks molten solder up through the tip. So to load it, you just press down like this, and to activate it, you press the black button, and there you go. So let's see if we can demonstrate that for you now. So load, first of all, and basically you just hold the sucker, put your soldering iron on the joint, get the solder molten, hold the solder sucker as close as you can and activate it, and you see it's just sucked up a bit of solder. Now it doesn't always come and get it all first time, so I've done it. I'll do it again for you now. You can see there we are. You can see that most of the solder is gone from that joint. Just demonstrate it on the other joint as well. So liquefy the joint, and there we are. Now the second method, and my preferred method, is to use solder wick. This is essentially just braided copper. And so what we do, I've just resoldered these joints so that I can demonstrate again. What you do is you put your solder wick over the joint and hold your soldering iron over the top of it, and as the solder melts, the solder wick just sucks up the solder. So there you go, you see. Solder's been sucked up by the wick. I'll demonstrate on the other one. So again, just hold the wick over the joint, press your soldering iron down on top, and as the solder melts, the wick should just suck up any solder. There we go. You can see that now pretty much all the solder is gone. I can move those legs around quite freely, so I'm able to take out the component. Simple. So there you are. That is my guide on how to solder. Bear in mind that this is quite simple soldering. I've only used through-hole components here. As you start to get smaller and you move into things like surface mount components, the soldering correspondingly gets harder. But bear in mind, this video is aimed at somebody who's never lifted a soldering iron up before. I hope you've enjoyed it. I hope it's given you some useful tips. As I say, it is just a technique. It's one of those things. I've done it for a long time now. I've been soldering for the best part of, I don't know, 18 years or so. So it's something that sort of I find fairly easy these days. But it's just one of those things. You'll try it once and you'll struggle, and then keep pushing at it and you'll get there. Over time, you get a feel for the relationship between how much heat you need and how well the solder flows and all that kind of stuff. So just keep trying at it, and it will click with time. If you do have any questions or comments, pop them down below. I will do my absolute best to get back to you, and I do mean that. I appreciate that it can be incredibly frustrating when you're watching a video and someone's showing how they do something and you can't quite work it out. So I will make an extra effort in this video particularly to get back to comments if people are confused about how to solder or whatever. Usual YouTube gumph as well, like and subscribe, all that kind of stuff. And I will see you in the next one, which will be the 50th episode. So I'll be doing a giveaway. It'll be some more 3D printed parts, so keep your eyes peeled for that. But anyway, until then, don't burn yourself, and I will see you in the next one. Bye for now.